Hi guys, in the previous lecture we learned to make the Find Me project. Okay, now what was it? Let's just recollect. We had a value, it was either 01, 02 or 03 which was being sent, and the LEDs were turned on. What was this value? This was the alert level, that is no alert, mid alert and high alert. Now for home automation, what do you think we would do? Instead of sending just one value, now 1, 2, 3. I don't count them as three values. I say it is one parameter or one type of value. Instead of sending one value, we will send four of them. And each of them we'll name them something. So we'll name the first one as device type, DEV type. Second one will be DEV code, that is device code. Third one is device param. And fourth one is a reserve value. Now what are these? Device type will stand for the type of the device that we are using. That is, it can be a light, fan, home automation, right? So we can control multiple types of devices. So we can say which type of device are we controlling. Because why did I split them as light and fan? Light will only require two parameters, turning on and turning off. Fan has a regulator, so it will require the speed control parameter too. So I just segregated light as one and fan as two. You can have other parameters also, other devices also. Then device code. Device code would be which light or which fan are you dealing with. So which particular device you want to turn on or off. And device parameter is what value are you passing through that device. Reserved is something you would use in extreme cases, otherwise we'll just keep that value as 00 currently. So what I've done is just split up into four parts. Three of them we might use, and yes, three of them we are going to use, and fourth one we'll just keep it reserved. If you want, you can use it for other purposes. So now just let us segregate and understand what happens how. Okay, so we have our device type, device code, device parameter and the reserve. So let's just see. Our device type will be light, device code will be which particular light, parameter will be either we are turning on the light or turning off the light. We'll have to give different numbers, right, to turn on the light and turn off the light, and some reserved value. Then another type might be fan. Device code will be which fan, the device parameter can be on, off or speed and reserved. So when we write, suppose we want to turn the light on. So what will we do? We'll say the light has a parameter of 0, 1. Which particular light you can have, I have just said two lights here. So you can have the light 0, 1 or 0, 2. Turning on, I have the value 0, 0, turning off I have the value 0, 1, and reserved I'm saying 0, 0. Okay, so these values we are going to fix to each particular thing. So what happens if you want to turn on the light? If you want to turn on the first light, you will send the code 0x00, 0x01, 0x00, 0x00. Okay, the first line altogether, you're going to send that code and your light will turn on. If you want to turn on the second light, then you will say 0x01, 0x02, 0x01, 0x02, 0x00 and 0x00. This will turn on the second light. What if you want to turn off the first one? Then you will again send a code 0x01, 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 0x00. So in GATDB, it isn't necessary that you have to write just one particular value like 0x01, 2 or 3. You can write multiple of them together. So we are going to send all this in one line. So similarly for fan, we can have a number 02. Which fan? It can be 1 or 2. Then 00 for turning on, FF for turning off. And speed can be any value between 00 and FF to control the speed value. What can we do in our case? If you want to see, yes, you can use PWM, correct, and reserved. So with this we can just say that we'll be controlling multiple devices, but instead of sending just one particular value, we'll send four values all at the same time, and after they are sent they'll be split up in our code. The values will be separated, and depending on the values which you have received, some action will be performed. Now let's go to making the custom profile. Okay, so now we have understood what we are going to do in the project. Let's get started with making the project. So we'll say file, new, project. Over here, make sure you will select this one, that is PSoC 4100 BLE, 4200 BLE. In design, I'll just name it as home automation and say OK. Okay. So I'll say BLE home automation since it already exists. So now what shall we begin with first? Making the custom profile for BLE. And what I'm going to do right now is I'll be controlling just two LEDs, red and green, or yeah, just red and green, that's it. You can control three, you can make the intensity control also, but what I'll show you is how to make a custom profile and how to use it in a very simple and basic manner. Once you know how the values are accepted and how the code works, you can tweak it as you want for any of your code, and you can make n number of devices work. So right now, first of all, let's take our pins. Digital pin. Since I said I'll be controlling only two LEDs, I'll take 2 pins. Then I'll just take my Bluetooth and I'll place it here. Okay. Now let's just configure the pins. I'll say red, no hardware, strong drive, high. Okay. And this one, let's say green, so just G. Okay. So we have configured our pins. Now let's go to Bluetooth configuration. Now certain things will change. Make sure that you pay attention. So in general tab profile, we'll be selecting custom. Then our server will be GAT server, and that is the profile role will be server, and the gap role will be the peripheral. Okay. Later let's go to gap settings. Make sure we've selected this silicon generated company assigned part of device address, and device name I'll say HA, that is home automation, or let's just write home. Let appearance be unknown, and remaining things as it is. Let's go to advertisement settings. Let these things be as it is. We are not going to do slow advertising, so let's just untick it, and fast advertisement remains as it is. Then advertisement packet. What will we send in the packet? Only the local name is enough. Okay. Then scan response packet. Do we need to send anything in it? No. Then security. Security, just keep it as it is. We are not changing anything. Now let's go to profiles. In profiles, you'll see the role of the custom profile is server. The profile name is custom. Role is server. In generic access, you will be able to see a lot many things. Okay, so what settings are we going to do here? First of all, check in the custom one. We'll first rename this. So we'll right click and say rename. We'll rename it to home automation. Fine. UUID. I'll change this UUID to a 32-bit one, and I'll write A 000 FFFF. Let the service type be primary. Now you will wonder, why did I choose this particular UUID? Okay, so there are certain UUIDs which are defined by the SIG and are assigned to the services and the characteristics. But there are certain UUIDs which are free and readily available. But SIG doesn't have any such protocol or criteria which says you cannot use the UUIDs which are already defined for other services and characteristics. You can definitely use those UUIDs. But then, just to be on a safe side, I chose a UUID which I found was free and not available to any other characteristic or service. Okay, so let's just keep this one, and we are going to use a few more in the future right now, which we'll see. You can use. Okay, then next go to custom characteristics. Here we again choose a UUID and let it be like A000 EFFF. Just again a random UUID, so that I just felt it is good enough for my design. Then in fields I write automation command, automation CMD. Then type we will select down here uint8 array. So what are we sending? We are sending 4 different types of parameters, that is device type, device code, device parameter and reserved. So we are going to choose a uint8 array, and the length of that array would be 4, since there are 4 parameters. In value we'll write 0, 0, 0, 0. So that can be the initial value. Okay, then we say read and write, both of them. Fine. Then we go to custom descriptor. Here I select a 32-bit UUID to be A000 DFFF. Okay, you can select any other if you want, no hard and fast rule. Type will be UTF-8S. Then in value, what will we type? We'll type home space brackets, and we'll type comma code comma param comma res. This is how we segregate, and then say OK. With this we are done configuring our Bluetooth. So now that we have said all the things, that is the pins and the BLE configuration, let us go to CYDWR and set the pins. Green has to be 3.6 here, and blue and red is 2.6. Okay, now that this is done, now let's go to main C. Now I have this code written. So like we begin for the previous code, for this one too, we will start from the main. So what do we do? First turn on the interrupts. Then we say start. Previously too we said start the BLE. Then we passed event handler in the previous code. In this code we are passing custom event handler. Okay, so let's see what it is. Custom event handler is just like event handler, not much difference. It has a switch case. Now that switch case, instead of just having two like we had previously, we have a few more things. Let's walk through them and understand what they are. This first one is for initializing the stack. Then second one is if the device is disconnected, then start advertising. Then we have get connect. So that is if device is connected, call function and take care of certain functions. That is connection handle. We are just storing the value in the connection handle. Then what do we have? Then we have GATS write request. So whatever request we are going to send from our mobile is going to be written into the PSoC board, right? So we have this write request case. So whatever parameter are we getting, that is the event parameter, is being stored in the write request param. Then what we are saying, if the parameter, write request parameter, is greater than the handle value parameter, that is what we set initially, that is 000, then we are doing something. Okay, now what we are doing, let's go into it. What are we getting first of all? An array. An array with 4 elements. Each element is 8-bit. Hence, we are storing the first element in the variable device type, second in device code, third in device parameter, and then reserved. Then, so what is happening here? First of all, whatever array we are getting, we are just splitting it up and storing it in different variables. Those variables are defined up here. UUID, device type, code, parameter, and reserved. And we have also defined some other things. These are objects which are used for these particular functions. Okay. So in this, what are we doing next? We are calling the device handle device function. This function is the main function wherein we are going to say what is going to happen when I receive some particular value. And then last, this sends an acknowledgement to our cell phone that yes, you have received the data. So let's look at the device handle code. So what do we have? If device type is 1, I've written it as an on-off device. Well, on-off device is a light, correct? We just turn on and off. We don't really control the intensity. Yes, for some lights you can control the intensity, but for tube light I don't think so anyone does it. So what do we have? First device type, that is 0, 1. Then if device code is 1, then write the value of R with whatever is the value of device parameter. Okay. So when we send something like 01, 01, 00, 00. So it is segregated into device type, device code, device parameter, and reserve. So device type is 01, device code is 01. So the first case will be executed. And then device parameter was 00. So we are effectively writing a 0 to our red LED and thus turning it on. And reserved, we really don't care what is happening because we are not taking care of the value reserved. Like we are getting some value, but we are not working with the value. So just let it be. Then I have another case that is for green LED in the similar way. So if you want for fan, what can you do? You can say if device type and write a switch statement which can take care of your fans. So I hope you understand this. Device type, device code, and device parameter. This is how we've split things and it is going to work. Now what we'll do, we'll build the code, clean and build, and then we'll program it into our board. So how do you program? You go to debug and say program. After you've built, the option will be available and we'll see how are we actually going to send the value through the GATDB and what action is being performed. Okay, so now I have already programmed my board. I will just reset it and I will start my phone and open the CY Smart app. So over here, as you can see, our home, the name that we set. Now in GATDB, unknown service, and we'll click on read and write, and then we click on hex. So how we'll be giving the value? What we'll do is we'll first turn on one LED. So that is the green LED, so which is 0x01, 0x01 for green LED, and turning on the green LED is 0x00. Then the reserved bit is, let it be 0x00, and we say OK. So you see the green LED is turned on. We'll say write again. Now we'll turn off the green LED. So it is 0x01, 0x01, 0x01 and 00. See, the LED turned off. Now we'll turn on the red one. So that's 0x01, 0x02, 0x00 for turning on and reserved. See, the red LED has turned on. Now we will turn off. So it's 1, 2, 1 and then 0. This is how you actually pass values and how it works. So what you can do is, this was only controlling one particular LED which was on the board. You have these pins, you can have relays connected to these pins, and you can actually control the appliances of your home.